So hey everyone, welcome to one more section in the project one. So in the previous video, what we did was we went ahead and got our Docker image and we pushed our Docker image to Elastic Container Registry. So now in this video, what we are going to do is we are going to go ahead and create an Elastic Container Service cluster, which is nothing but a cluster of EC2 instances, or we can also run it in the Fargate capability, where we would have the serverless aspects where the EC2 instances are managed by AWS themselves. But to keep it simple, we are going to go with a T2 micro or a T2 small set of EC2 instances in our cluster. And then we are going to run our Docker image, which we built in the previous lecture, as a task definition within our ECS cluster. And we are going to expose this container as a service on a load balancer. And our end result is going to be that when we go to the load balancer's DNS name and we hit the context path /app/students, automatically it should connect to the database and retrieve our data for us. So that is going to be our end result after finishing this lab. So let's get started. I'm already logged into the AWS console and I'm logged in as the root user. So the first step that I'm going to do is create the ECS cluster. But before that, I would like to go ahead and create an application load balancer that we are going to use for path-based routing capabilities. And we are going to integrate it with the Elastic Container Service, the cluster that we create. Okay. So let's go ahead and get started by creating an application load balancer. So I'm going to go to the EC2 service. So in the EC2 service, I'm going to scroll down on the left side and go down to load balancers. Okay, so let's go ahead and create the load balancer. Let's click on create load balancer. So we are going to go with application load balancer in our use case, which supports the HTTP and HTTPS protocol, as well as path-based routing functionality, which is the typical load balancer that you would use in order to run microservices and containers. So let's go ahead and create an application load balancer with the name being called as Microservices ALB, just to give a sample name. And right now I'm going to keep it as internet facing. So we will be able to hit the DNS of this load balancer from the outside. And the listener is going to be HTTP on port 80. And I'm going to choose all the availability zones within the default VPC within the region Northern Virginia. Under configure security settings, it's just giving us a disclaimer stating that we are using HTTPS, we are using HTTP rather than HTTPS, which is totally fine for ourselves right now with this demo. So in terms of the security group, I'm going to create a new security group. I'm just going to call this security group as Microservices ALB. Let me also denote SG. So for this, right now we have port 80 open to the outside world, which is totally fine. So for the configure routing, the target group name that we are going to give is nothing but default TG. But we are not going to use this target group. We'll be creating the target groups from the Elastic Container Service while we create the service. But for right now, just to go through this entire 6 steps in order to create the application load balancer, we are giving a default target group, which probably will not be using. So everything else can be the default configuration. You don't need to give any other configuration. And if you are not familiar about any one of these configurations, you can always take a look at the EC2 section where we created an application load balancer with more detail. Okay. So we are not going to register any targets as of now because we don't have any EC2 instances that have been created by the Elastic Container Service. So we will right now not register any instances, but later we will allow Elastic Container Service itself in order to register the containers directly to this application load balancer. Okay. Click on review and click on create. So in the process that our load balancer comes up from the pending state or the provisioning state to the active state, in the meantime, what we will do is we'll go ahead and create our Elastic Container Service cluster, and then we will create a task definition, and finally we'll create a service and we will test it out. Okay. So let's go to Elastic Container Service, click on services, and on the bottom you can see Elastic Container Service will be under container section. You can always search for ECS. So in Elastic Container Service, we don't have any clusters. So on the left side nav bar, just click on clusters. We don't have any clusters right now. Let's go ahead and create one. So I'm not going to go with just only networking configuration. because that's powered by Fargate, where we will have no clue where our containers are running on which host. That comes under the serverless aspects of AWS with ECS. And even EKS right now, which is Elastic Kubernetes Service, also has a capability of Fargate, which they recently introduced in December 2019. But now we are going to go with EC2 Linux with networking, where we are going to have an EC2 instance. And this is nothing but this configuration is a cluster of EC2 instances which has Docker installed, and probably I would call it as a Docker Swarm. So if you guys are familiar with Docker Swarm, you will be able to immediately grasp most of the concepts of ECS with EC2 with networking, or even with just networking alone with Fargate. So it's nothing but a cluster of EC2 instances with Docker installed. Okay. So let's go to the next step. So we are going to give a cluster a name. So I'm going to call this as microservices, the cluster name. I'm not going to create an empty cluster. I'm going to go with a cluster with on-demand instances. And I'm not going to choose M5 large because that's pretty costly. I'm going to see if there is T2 available. So let me just scroll up. Okay, so probably after the M5, we'll see the T2 series. Yep, so we do have the T2 series over here. So I'm going to go with T2 small right now. And I'm just going to have only one instance in my cluster, but at any point of time, I can do auto scaling for the cluster. That was also supported using capacity providers in December 2019, I believe. So for right now, it's just going to be one EC2 instance just to stay within the, kind of within the free tier, but not get a lot of cost. We are going to go with T2 small. We can also go with T2 micro, but that's totally fine. But for right now, we are going to go with T2 small. And the root EBS volume is going to be 30 GB. The EC2 AMA ID you can see over here, it's pre-populated because it has Docker already installed. It's a specific AMA ID that is dedicated towards Elastic Container Service. And for the key pair, I'm going to choose my key pair so that at any point of time, if I want to troubleshoot anything, I'll be able to log into that EC2 instance. Or even if I want to go ahead and modify my a Docker logging driver, I will also be able to just log into the EC2 instance. So that's the reason why I'm choosing a key pair. For the networking configuration, I'm not going to create a new VPC because my load balancer is sitting within the default VPC. I'm going to also place this within the default VPC and choose all the 6 subnets. So the same set of subnets that you chose with your load balancer, please do choose the same set of subnets with your Elastic Container Service cluster too. So once you chose all the 6 subnets, we are going to use a subnet setting for auto assign public IP. But we are going to create a new security group with port 80 open to the outside world for the ECS cluster. But later we are going to modify this so that all of the traffic can come only from the load balancer. Okay. And regarding the container instance IAM role, as well as the CloudWatch container insights, don't need to worry about this much. It's nothing but it allows ECS to go ahead and do other API actions on your behalf in terms of creating EC2 instances, creating an auto scaling group, a launch configuration, and so on. So it's going to stick to creating a new role for that. So let's go ahead and create this cluster. So what's going to happen is it's going to create a CloudFormation stack where it's going to go ahead and choose the same VPC with the subnets and the availability zones, but it's going to create an auto scaling group for us with min, max, and desired as one EC2 instance. And it's also going to create a launch configuration with the AMA ID that we mentioned over here. And then it's going to give us an output and our cluster will be created. And in the meantime, we can also check the status of the load balancer while this gets created. So load balancer should be up and running within a few minutes, shouldn't take much. So let's scroll down over here and take a look at the load balancer. So the load balancer right now is in the active status, which means it's provisioned and it's successful. So even our cluster is ready to go, which means if our cluster is ready to go, the best way to check whether our cluster is ready is to check your EC2 instances. So you should have one EC2 instance that has been spawned up. So you can see over here, you should have one EC2 instance that has been spawned of T2 small with the name from the EC2 container service with our name of the cluster, which is the microservices, which was the name of our cluster. Right? So let's wait for this instance to start up. So it's in the running status. Let's also wait for the instance to pop up on our ECS instances tab. So right now we don't have any. Let's refresh this. Cool. We have one container instance over here, which is nothing but our EC2 instance that was spawned right now. The memory available is around 1.9 GB with one virtual CPU. And the Docker version that it's running is 19.03.6, which is the latest version. And the agent version is nothing but your ECS agent version that is running within that EC2 instance in order to manage that EC2 instance. So Therefore, this agent version is your ECS agent version. Okay. So now the next step that we are going to do, since our cluster is ready, the next step that we are going to do is create our task definition. Okay. So let's go to task definitions on the left side. So task definition is nothing but your Docker configuration, something that you studied in the orchestration section in regards to port mapping, in regards to how much memory and CPU you're going to give. All these things are all Docker related configurations in terms of which image you're going to use. So all these configurations are going to be given on the task definition configuration, and your load balancer configuration in terms of your Route 53 configuration, in terms of service auto scaling, all those are going to be on the service level. So task definition is the most lowest level in terms of how many containers would you like to run and all those settings. Okay. So let's go ahead and create a new task definition. And again, over here, it's going to ask us whether we are going to go with the Fargate capability or the EC2 capability. So the Fargate capability, for us to launch it, we need to have a cluster that supports Fargate capability. But since we chose a cluster that supports EC2 capability, let's go with EC2 capability for our task definition. Let's give the task definition a name. So we are going to give it the name student task def. And the task role over here denotes as to whether your EC2 instance would like to talk to other AWS services. And if it has to talk to other AWS services, you need to present a task role or an IAM role for your task definition, including an execution IAM role, because this allows you to go ahead and talk to CloudWatch and put out all of your logs to CloudWatch. And at the same time, if you want a task that is your container where your application is running in order to access S3, you need to provide a task role over here that has access to S3. Okay. So other than that, the network mode over here is pretty simple because it's again Docker's concepts for networking. The default one sticks to the bridge networking mode on ECS. So we are going to stick to the default, which is nothing but bridge networking mode. So that means on all EC2 instances of our cluster, we'll be able to view the application. It's pretty cool. So other than that, we are not going to give the memory and the CPU over here. We are going to add a container definition. So let us add a new container definition, call this container student, but the image is going to come from ECR. So let us open up ECR, Elastic Container Registry. And let's get the URI endpoint of our Docker image, which is nothing but this endpoint. Grab the endpoint, paste the endpoint over here, and you can also put tag as latest with a colon latest. And the memory limits that we are going to have over here is we are going to have a soft limit as well as a hard limit. Soft limit is going to be 512 MB and the hard limit is going to be 1024. The reason is because if suppose your application starts consuming more than the soft limit, you can specify a hard limit. Okay. And the port mapping, we know that our container within which our application is running, the application is going to run on port 9000. So therefore, our host port, what we are going to do over here is we are going to give host port as 0 and the container port as 9000, which is going to do dynamic port mapping. So within the container, the application is going to be on port 9000, but outside of the container, it's going to be exposed on a random port within the port range of 32,000 to 33,000. And you will see this once we run this container as a service. So other than this, most of the other configurations you don't need to worry about right now. I'm just going to skip these configurations. In order to understand these configurations more clearly, you can always use the AWS docs. And you can always have environment variables passed into your task definition. And this can directly be a key value pair, or you can always go ahead and specify value from where you are going to get the value from systems manager parameter store. If you do have all of your parameters stored there. So something along the lines of database host name endpoint, or your DB name, or your database username, or your database password. All these configurations, the best practice is to give them as environment variables. Okay. And you can always store these environment variables in systems manager parameter store and use the value from and in order to get those variables from that. Okay. So we will have that as a separate lecture a little bit later so that you get an idea as to what this is. So other than all of these settings, we are going to enable log configuration so that we'll be able to view all of our logs of our application that is running within the container in AWS, in Amazon CloudWatch, inside a log group and a log prefix of ECS. So other than this, we don't need to add any other configurations over here. Let's go ahead and click on add for the container. So let's scroll down completely and click on create for the task definition. So once you create the task definition, our step is ready in order to do the Docker configuration. So next thing that we have to do is we have to create a service which will manage this task definition, in the sense that how many replicas would you have, how would you like to register this, whether to a load balancer or to Route 53, and also I mean, how would you like to do service auto scaling? Like if suppose the container metrics are in terms of CPU utilization is greater than 70 or 80%, how would you like to do service auto scaling? So all those configurations are denoted on the service level. So in order to do that, we have to go back to our cluster, go down to microservices over here. But just one small note over here, before creating the service, what we are going to do is we are going to modify two database security groups right now. So not necessarily two databases, it's going to be one database security group and one EC2 instance security group for the ECS cluster. So let's go ahead and do that. The first thing that we are going to do is the load balancer has to get all of the containers that are running on the T2 small host registered to it. So therefore, on the ECS instance, on the EC2 instance that we have, which is the T2 small, for that security group, we need to open up port 80 to the load balancer. So let's do that first. So on our EC2 instance over here, let's take the security group and let's check the inbound rules. We are going to modify this inbound rules to specify that all ports or all traffic is going to go to the load balancer security group, which is nothing but we called it as microservices ALBSG. And we are going to remove this 80 rule, which means that whatever container is spawned on our host, all of that inbound traffic should come only from the EC2, only from the load balancer to the EC2 instance. So that's the reason why we need to add this first. Let's click on save rules. And the next thing that we have to do is our ECS cluster, the instances that run within that cluster, the applications that run within that cluster should be able to access the database. So therefore, we have to add 3306 port to this security group ID. So let's copy this security group ID, which is nothing but our ECS instances security group ID. And let's go to the, I think the databases security group was the default security group that we had. So I think this is the one for the database. So yeah, this is the one. So I'm going to add another inbound rule over here. And I'm going to add that rule to MySQL and Aurora port, which is 3306, to this security group, which is nothing but our ECS container security group. So the reason is because the architecture that we have right now is we have a database which has its own security group. We have an ECS cluster that has its own security group. And then we have the application load balancer that has its own security group. So now what we need to do is, in our ECS cluster security group, we need to specify the inbound to come from the application load balancer. In our database security group, we need to mention the inbound should come only from the ECS cluster. So in that way, we are tying down the security groups with best practice. Okay. So now once we have done this security group modification, the next thing that we are going to do is create the service. So going back to the ECS tab, clicking on your ECS cluster, clicking on services, let's go ahead and create the service. Let's click on create. And over here, we are going to go with EC2 capability. And the task definition is going to be only this one because that's the only task definition that we have. The service name that I'm going to call this is student service. I'm going to run it as a replica, not as a daemon, because daemon runs it on all of the nodes of our on our ECS cluster. So if at all we have one more EC2 instance that we add to the ECS cluster, automatically the service is going to be run over there. So that is called as daemon. It's nothing like a background process. So what kind of applications would you possibly run as a daemon would be something in regards to a log agent or a monitoring service and so on, like Prometheus, probably even a node exporter, which would like to scrape metrics from all of the nodes in your cluster. So those kinds of applications, you would possibly run it as a daemon. But right now, ours is just going to be a replica. And the deployment strategy that we are going to go with is a rolling update. And the placement templates is we are going to go with AZ balance spread, but there are other placement templates that you can go, like one task per host, bin pack, or even a custom placement template that you create. But for right now, we are good with these settings. Let's click on next. So instead of going with the Route 53 integration, what we are going to do is we are going to go with application load balancer integration. And the service IAM role, in order to hook it up to the application load balancer, is going to be created by ECS itself. But we are going to choose our application load balancer name over here. If you have multiple ones, just click on the drop down and choose. But right now I have only one with me. And you can see over here, the container port, which is 9000, and the host port, which is 0, we have to add it to the load balancer. And the production listener port on the load balancer, I'm going to use is port 80. The target group, I'm going to create a new target group called as student service -tg. And over here, the path pattern that I'm going to go with is nothing but /app star, because we know that we have added a context path of /app to our application. So therefore, the path pattern is going to be /app star. The evaluation order is going to be 1. The reason is because we already have the default target group for the rule path of /. So anything that's going to be /app specifically is going to be targeted to this particular target group where our containers will be registered, which means our applications will be able to automatically get the traffic in. Okay. So this health check path is going to be a specific path, which is going to be /app /students, /app /actuator /info. So this is a specific path in our application, which is going to be used for the health check. So we already have the actuator endpoints added to our pom.xml. So that's already there within the application. So you don't need to worry about that. So if you follow along with this same configuration, you'll be able to get it. So this is in regards to Spring Boot actuator, which is nothing but a set of endpoints that allows us to track the metrics as well as the health checks for a specific Spring Boot application that we are developing. So we will obviously have this health check path if we have added Spring Boot actuator to our dependency in our pom.xml, which we have, and that's you already have that code with you. Okay, you can just take a look at pom.xml and you should be able to see the dependency called actuator over there. Okay, so after doing all of these configurations, you can scroll to the next page, and over here we are not going to do service auto scaling just to keep things simple, but you can also configure service auto scaling where you would possibly configure the min, max, and desired for the number of tasks. And you can also specify based on any metrics in terms of CPU utilization or memory utilization and so on. How would you like to increase your number of tasks within your cluster in order to do load balancing? So for right now, we are going to give it as do not adjust the service desired count. But if you do like to configure service auto scaling, you can always do that. Okay. Let's click on next and let's go ahead and create the service. So once we have created the service, the end result is going to be we are going to get a task that is going to run. So our application is going to run within the task. It should be, technically speaking, it should be able to go ahead and connect to the database, and it should be able to register itself with the load balancer. And then when we hit the load balancer's DNS name, automatically we should get our application's data from the database. Okay. Let's check this out. So let's click on create service. So it's created the target group, also added the rule. So it's creating the IAM service policy. Let's just wait for a second. And once that is created, it will go ahead and create the service. So the service is also created. Let's go ahead and view the service. So right now we don't have any tasks that are running. Let's go ahead and refresh this. So we have one task that is in the pending status. Again, refresh it once more. It's still in the pending status. Let's probably click on this task. And you can see on the bottom, the container that was spawned. I mean, you may not be able to see the IP address over here, but I'll show you the IP address on the load balancer once this is spawned. So right now it's in the running status, which is good. Let's take a look at the logs over here. Probably refresh this. Just give it a minute or two. Okay, so it started. Let's see if we are getting any errors or whether it's successfully started, whether it's able to connect to the database. So I think it has started the application. I think it was able to connect to the database. Let's just take a look at it. So it was started on port 9000, which is pretty cool. Okay, so I think it was successfully started, and yes, you can see over here, we have the student ID equals 1 and the name is Akshay, which means it was successfully able to connect to the database thanks to a security group configuration. But let's take a look at it, whether it was able to connect itself to the load balancer. So on the EC2 console, scroll down towards the load balancer's target group and click on your target group, which is student service target group. And when you take a look at the targets, you can see over here that it's randomly allocated a port from 32,000 to 33,000 in that range, because we chose dynamic port mapping with 0 as the host port. And you can see the healthy status over here because the path for the health check endpoint has succeeded, which is nothing but the app/actuator/info. Now let's take a look at our load balancer's DNS name, and let's see if we are able to get our context path redirecting properly, app/students. And when we type app/students, we should be able to see all these values. Brilliant. So the request goes through the middleware, through our Spring Boot application, which retrieves the data from the database and sends it back as a JSON response. So this is pretty cool. So our endpoints successfully work. So next step that we are going to do is we are going to take this load balancer's DNS name and we are going to register it in Route 53. So the way that we would possibly do that is to take this DNS name and go to Route 53. So in Route 53, if you already have a domain name registered, you can take a look at the hosted zone. I do have one registered over here. I can go ahead and create a new record set and I can call this as api.zerosinitiative.com or api-backend or api-student.zerosinitiative.com with the type being a CNAME record, or you can shift it to an alias record because alias works with load balancers. You can just click on this load balancer from the drop down, which is nothing but your ALB, and you can leave it as a simple routing policy and click on create. So it's going to create a new DNS name for you called as api-student.zerosinitiative.com. You can take this DNS name and open up an incognito window to test it out. So we have the incognito window over here. You can directly paste it and type /app/students. And we should be able to see the same output. Awesome. We are able to see the same output. So we have also done the Route 53 translation for the load balancer. So I hope you guys got a really good idea that we were able to deploy our Docker image onto an ECS cluster of EC2 instances with all of the features that ECS gives us. And then we have registered our container to the load balancer with a DNS name where we are able to access the endpoints, which goes through our backend onto our database and fetches the values for us. And we have translated the load balancer's DNS name to a very nice domain name such as api-student.zerosinitiative.com. So I'll open up the diagram right now and I'll show you the implementation that we have come so far and then what implementation is still left for us. Because ultimately we don't want to view JSON. What we would like to view is something in regards to an Angular application with a nice table. And the table is going to give us a very nice view. So let's take a look at in the future lectures as to how to go about deploying an Angular application, how to clone the source code for the Angular application, where would you clone it from, how do you build your Angular application, how do you upload the source code to S3 and have CloudFront in front of it, with all of these features that CloudFront and S3 provides us with. So let's take a look at that in the subsequent lectures. But for right now, I'm going to go ahead and show you the diagram in terms of the implementation so that you understand as to where we are right now. Okay. So this is the diagram that we were first discussing in the first introduction lecture to the project. So right now, the place where we are is that we already have our ECS cluster set up with auto scaling across one EC2 instance right now, but you can always convert that to 2 or 3 EC2 instances into your ECS cluster. But it's just that we don't want to have the cost aspects very high for doing this project, that we just stuck with one T2 small instance. And then we do already have a load balancer over here. And this load balancer's DNS name is something that we registered, which was called as student-api.zerosinitiative.com. And it was registered to Route 53. And then we also have our database, which is nothing but our RDS instance that we set up in the third or the fourth lecture, I believe. And this RDS instance has all of our data in terms of our student database and our student table. So each and every request that comes via our Route 53 endpoint over here goes to our load balancer, which goes ahead and requests for the results from our container within which our application is running. And this container is running inside the T2 small EC2 instance. And now this has connectivity all the way to the database, which is going to retrieve our data from the database and send that back as a response to the application load balancer, which is going to send that back as a response to our DNS name. That's the reason why we can see the JSON response. So our architecture until now over here has been successfully created. You can also have your own customized endpoint for the database, but I just skip that right now. You guys can probably just figure it out, like how you did it for the load balancer. You guys can figure it out as to how to do it for the RDS database. I just take the RDS database endpoint and then translate it to a very nice endpoint on Route 53 if you already have your domain name created, not as an alias, but as a CNAME target. But now the implementation that is pending is something in regards to our front end. So this is our Angular application. So this Angular application right now is going to be uploaded to our S3 bucket with all of the build artifacts being uploaded to the S3 bucket. We are going to have a CloudFront distribution in front of it with an origin access identity policy that states that you can only access the objects from the CloudFront distribution, not directly from the S3 bucket. And we are also going to have a web application firewall. That's an optional step. If you guys want to include that, you can always include that with CloudFront. And then register the CloudFront DNS name with a translation to Route 53, which is nothing but our frontend.zerosinitiative.com. So when we go to frontend.zerosinitiative.com, our end result is going to be a table which is going to list all of the IDs and names, which is 1 Akshay, 2 Ashray, and 3 Aditya. And that request is going to go all through the middleware to the backend, and it's going to come back to the front end, and we are going to visualize it in a tabular format. So I hope you guys got an idea as to where we are right now and what are the things that we are going to do in the next few sections. So I hope you guys understood the ECS. If you have not, please do go through the previous lecture in the orchestration section for how Docker works and for how ECS works in terms of containerization. I'll catch you guys in the next section where we discuss about the Angular application that we are going to clone and build and then upload the contents to an S3 bucket. Okay. So thank you for attending this session and have a great day, guys. And please do stay safe and take care.